we want to compare these 4 different groups, we need to use a thing called Anova. And to calculate Anova is going to take a couple of additional steps than what we've done so far. The first thing we need to do is find the sum of squares for the total, and then we'll do the sum of squares for the different groups. So you can come back here and see that the total, the average, so it would be our grand mean, if we put everybody together, is this number. I'm just going to paste it here so I've got it. So it's 123 centimeters. So what I need to do first is, I'm going to go ahead and hide those. This is going to be the observed minus the grand mean. So that is distance minus the grand mean. Right, I'll do that for all of them. Now I need to take that and square it. So this is observed minus mean squared. And what happens when we do this is we get rid of all of our negative numbers. So everything's positive now. Great. Okay, so now I need the sum of squares total is equal to the sum of these. This number. Okay, great. Now, slightly different thing we need to do. We need to calculate the sum of squares between. To do that, we're going to take all of our averages here, and we're going to subtract those from this number. And we're going to do the same thing. Right? So this is the mean of each group. And this is the mean of the grand total. Oop. So this is group minus total. There we go. And we will now square that just like we did before. Great. And so the answer of the sum of squares between is simply the sum of these numbers. All right. Now to get our mean squared between and mean squared error. Mean squared between is going to be our mean, or sum squared between divided by the number of groups minus 1 equals this divided by, we have 4 groups, so 4 minus 1 would be 3. To get our mean squared error, it will be, we will take our total sum of squares, just bring the value over here. So our sum of squared error is the total sum of squares equals the total sum of squares minus the sum of squares between. So that number. Oh, you know what I didn't do here? There's an additional step. I need to multiply each of these by the count. Paste values. So now I will take this times count. There we go. Bring that down. Good. So my sum of squares between is not this number, it's this number. Fantastic. All right. My mean squared error is the sum of squares error divided by the total number of observations minus the groups. So it's n minus groups. That means it's this divided by this number, and we have 4 groups minus 4. There we go. So our mean squared error is this number. Finally, to get our F ratio, F is mean squared between divided by mean squared error. So we will just take mean squared between divided by mean squared error, and our F is gigantic at 244.4. If we want to see that in a p-value, we could do equals f dot dist. Our x is this. Our degrees of freedom 1 is the number of groups minus 1, 3. Degrees of freedom 2 is the count minus 4. And we can say true. We're going to say false, actually. There we go. False. That's the part of the tail that's way out there. So basically 0. Basically 0. So the chance that all of these means are the same is basically 0. We will reject the null hypothesis of f that says they're the same and conclude that at least one of them is different. Okay, that's a lot of steps to do it by hand. It's much easier to do this by computer. We'll go to XLSTAT, modeling data, Anova. Our quantitative variable is distance. Our qualitative is frog type. Hit OK. It's going to think for a moment. So that's the exact same f value that we calculated. You can see here, 244.45 and 244.45. So exactly the same. There's our degrees of freedom, and you can see all these values are the same things that we calculated, just kind of organized slightly differently, and they don't show the digits. They round to the largest number. There we go. Awesome. So we can calculate it by hand using lots of steps, or you can calculate it using XLSTAT, which is a lot faster and easier. But there we go. And while we're here, we have also produced a regression. So we can look at our regression results. First thing we can look at is our R-squared value. So knowing that it is what type of frog it is explains 18% of the variance in how far it jumps.